So what I was saying is like to now we have been given some numbers. They will pass some numbers through the main function. See, when you look at the main function, we have these numbers being passed. See, one, that. So we have to find the square root of these numbers.
Okay.
Okay. Okay. So let's assume we are to find the root of the square root of 16. Okay. So
Okay.
square root of 16 is um, 4.
Yeah.
So with 4, we realize that 4 multiplies itself to get this one, to get the 16.
Yeah.
So what we are going to do is we are going to kind of start from 0 and
Okay.
then say that, uh, okay, let's initialize root to say 0. So meaning that we are starting from 0 and multiply 0 by itself and then we increment it till we get to 16, which
Okay.
is our n. So n is equals to 16.
All right.
So we increment till we get to n. So
Okay.
now what this root is coming to do is this root is coming to multiply itself. So
Mm-hmm.
anytime it is increased, it multiplies itself to check whether it is equal to the n value.
Okay.
You see, so root times root. Okay. So we say that if root times root is equal to the n value, then it means that it is um, um, the root value is the square root of the n.
Okay.
Do you get it? So if this is equal to
And
n, it is double sum, n return root.
okay.
You see, so at this point, root is our resource for the root square root of whatever n is.
Okay.
So let's take like 25. Square root of 25 is 5. So to
Yeah.
get the 5, what you have to do is multiply
Start
because we'll
from.
be incrementing roots all the time. So when
Mm-hmm.
it gets to 5, it multiplies itself. So when
Mm-hmm.
it is equal to the 25, it means that that is the uh, square root, that's the
That's okay.
resource. So we return
Okay.
roots.
Okay. So let me see if I have understood to this point.
Mm.
So we are supposed to find the square root of a given number, which is n,
N, yes,
and when we pass that number in the program, it's supposed to give us the square root of that number.
yes,
Now, to do that, we need to, we know that finding the square root of a number means that you are multiplying the number by itself.
itself,
And the general concept is that you multiply one number by itself. So you give it the variable root.
yeah,
Okay. So, but you also have your variable that you are looking for, which is probably 16 or 25 or
yeah,
64,
yeah,
right?
yeah,
So that is going to represent your n.
yes,
And you are going to initialize the root to 0 because you want to start counting
from
to up
0.
to, yes, so you want to start counting up to
No,
where
n,
root is equal to n.
yeah,
Okay. So when you do that, you just multiply. So if you start from 0, 0 by 0, what is it? It's 0. Okay.
yes.
So
Then
the
you
n
move
is
on.
0. It doesn't meet the condition.
Yes,
1. So you move to 1.
yeah,
1 times 1
yeah,
is equal to 1. Is it equal to 16 if we are using 16? No.
yeah,
So it doesn't meet the condition. 2
yes,
by 2,
yes,
4 doesn't meet the condition. No. So 3 by 3,
yeah,
9 doesn't meet the condition. No. So 4 by 4, 16. Okay, so 16 is equal to n, which is equal to root. So root
Yes,
is equal to n,
yes,
and then return root. Okay,
root.
all
Yes.
right.
So this is the code. So
Okay.
what I did is that um, we were only given this
Yeah. N.
yes n. We're only
Yeah.
given this argument. So
Yeah.
we can't do much with this. So we have
Mm-hmm.
to create our own thing, and then
Yeah.
so with this, I just created this function, support function,
Okay.
and then I
Okay.
have two arguments. Why two arguments? Two arguments because one will take the incoming n.
Mm-hmm.
Okay, so this is the n. So one will take the incoming n, which is the number, and then the other one will take care of my kind of four,
Okay.
the number that will multiply itself.
Yeah.
Okay, so
All right.
here my base statement is that if root multiplied by root is less
It's
than
great.
number, so
Greater than. Yeah.
sorry,
Greater
is
than
greater
number.
than number, meaning
Mm-hmm.
it is not it. So let's get to the question. The question says what? It says write the function. If n does not have a natural square root, the
Mm-hmm.
function should return -1.
-1. Okay.
So once that multiplication is not equal to n, if this is not equal to n, this is even above. So we have even passed the n,
Yeah.
the n value.
Yeah. Yeah.
So it means we should return what? -1.
-1.
Okay.
Okay.
Else if root times root is equals to the number, then it means we should return what? Root.
Yeah. Root.
This is what
Okay.
I was explaining earlier.
Okay.
Okay. Else do this. So else means that in this case, how will I push this? Okay. Else means that after satisfying this, we return. Now, what about the other side? This is where we start incrementing we can
Okay.
equally say root plus plus,
Mm-hmm.
but I don't know. I prefer using this one. I think root plus
Okay.
plus will also work. But
Mm.
because I want to call this function, this is
Mm-hmm.
recursive call. So
Mm-hmm.
once it is called recursively, this will
Mm-hmm.
automatically will be increased.
Okay.
Okay, because this function has the roots.
Mm-hmm.
So if you call this function severally,
Mm-hmm.
this will continue increasing anytime the function is called.
Okay. So
Okay.
let's stay on this for a while. I'm trying to wrap my head around it.
All
Okay.
right. All right.
So the function has two arguments, which is number and then root.
Yeah.
Okay. And the return is supposed to kind of increment the um, number so that we can um, have the equal, we can be able to return the root,
Yeah.
right?
Mm.
So in the support function, we already have um, we have the number and then the root.
Mm.
That bit is where or
You
you
get
me
confused.
kakra.
Okay.
Yeah. Okay.
Okay.
So
Let
okay,
me.
let me try again.
Okay.
Let me try again. So in case we have 16, let's represent it by a number 16, right?
Okay.
So let's start from the top.
Mm.
Root times root is greater than 16. So if it is 0 times 0 is not greater than 16,
Mm.
no. Okay, I think I'm getting it. So root by root is greater than, which means that probably 5 times 5 is greater than 16, and then we'll
Yes.
return 1. We'll get out
Yes.
of the A.
Yes.
So that
Yes.
will return -1.
Yes.
Else, if root by root is equal to 16, we return the root.
Yes.
But we haven't. iterated to get to the number that root times root is going to be equal to 16,
mm,
right? And
mm.
that's why we have to come down to this what friend this recursive function,
Okay, so here
which is the
you
return.
know that
Mm-hmm,
we are starting from zero.
mm-hmm, yeah,
Let me go down so that we know where we are starting from. You see this function, we pass
yeah,
zero and
yeah,
then the n, which is in the
yeah.
main function.
Mm-hmm.
So the zero meaning that root is starting from zero.
Okay,
Okay, so here root, obviously before we get to let's assume it is number is 16. Okay,
okay.
so before we get to even 16, this one has gone through a number of recursions.
Recursions, okay.
So when we get to this side and it is equal, return, give me root, give me the
Root,
4,
okay, okay,
else go through again.
okay,
You see,
okay,
else
okay,
go through
okay,
again. So
okay,
it will go
okay.
through till this statement becomes
Mm-hmm,
is it
mm-hmm.
false? Yes.
Yes, okay. I think I get it. Okay, so let me try again.
Mm,
So we have 16.
mm,
I understand the first, I understand the second. Now, the third and the else is where we are looking at.
yeah.
So the support function has 16, and then initially it had 1. It traversed, initially was 0, and
Zero,
then we
yes.
added 1,
1,
right? Now we are comparing if the root of 1, that's
mm,
1 times 1, is going to be equal to 16.
yes.
No. And then we'll add another one, which is going to
Yes.
be 2.
Yes.
So, okay. All
So
right.
it will
I get
go
it.
through till we meet
Yes.
the condition, like we meet the this is equal to that. If it
Okay.
is not equal to, then you turn minus 1.
Okay.
You see.
Okay. Okay.
So the reason initially we were saying that the why the two arguments, it is because you have to make room for the n, the incoming n,
Okay.
and
Okay.
then also what we are going to use, which is the root.
Okay.
So when you see number, it
Mm-hmm.
is actually the same as the n.
And okay. Okay.
So that is why we did that.
Okay. 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 All right.
So with this, meaning that your other function, you see this is the function that we were given, the prototype.
mm-hmm. Yeah.
So you need to call this. Okay,
Mm-hmm.
you need to call this
Mm-hmm.
for your function to work, like for your
Okay.
so that's why
Okay.
we came here. We said that and this statement is not even complete, the
Mm-hmm.
top one,
Okay.
because we didn't make room for negative numbers.
Yeah.
But because here we didn't explicitly have the n here, we have to do
Mm-hmm.
it here. So when
Mm-hmm.
n is less than that, we have to also take
Okay.
care of.
Okay. Okay. Okay.
Yeah.
Okay. Could we have handled it in there?
Yes, we could have handled it here.
Okay.
Any which way, like it will work,
Okay.
because it's the same. Like you could have even equally say that when
Root
number,
by root.
yes, because this
No.
is actually number.
Okay.
So when number is what less than 0, return
Yeah.
minus 1. Or we
One.
could have
Okay.
equally added this one too, because they are all
Yeah. Oh.
returning
Okay.
minus 1.
Okay.
So we could
Okay.
have also said that, or
Oh.
yes,
Okay.
sorry,
All right.
or and then we will
Oh.
add down.
Okay. Okay.
So
All right. All right. All right. All right. All right. Okay. So it means that if we had added that one, we wouldn't have even had
yeah.
to.
So
Oh.
it would
Yeah.
have been only one
Redundant.
statement
Okay.
here.
Okay.
Yeah.
Okay. 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 Now, let's scroll down to your recursive function. Let's see something.
Yeah, it does that.
That's it. Eh?
Yeah.
Okay, so the recursive function is actually not calling itself.
Okay, here, um, this is calling
Yes.
itself the
Yes.
support function, but the
Okay.
recursive
Okay.
function is calling the support function.
Just okay. 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 I get it. So it's kind of it's calling the recursive function by extension.
Yes,
That's what's happening.
yes,
Okay. Okay.
because
Okay.
we have to pass in the values. So it
Yeah.
is this function, the recursive function, that is actually giving the
Mm-hmm.
values to
Mm-hmm.
the
Okay.
support function.
Okay.
This function, this value is given to us by the main, given to the
Mm-hmm.
recursive function by the main.
Mm-hmm.
So it's like they are all linked together, and the
Mm-hmm.
and this recursion is also giving it back to the support function.
Mm-hmm.
Yes, so there should be a linkage for the code to work.
Okay.
So here we don't know the values of n, but
Yeah.
we are saying that whatever the value of n is, we should be able to write the code to, as in, contain those
Mm-hmm.
values.
Mm-hmm.
Yes.
Okay. And zero. Okay. Okay. Let me. Okay. All right. Yeah. So.
Sorry.
Oh, no problem. No problem. So, I wanted to explain the last return for the recursive function, a prototype.
This one.
Yeah, a prototype. No, the last one.
Okay.
The definition of a prototype.
Is it this one?
Yeah. Yes. So again, by extension, um, it's
Wait.
returning the support function, which in this case, the n is actually the root when you go to the support function, right?
Yes. N and
Okay.
then the roots. Yes.
So n is your root, and then the zero kind of is your
No, n is the values that will be passed. So
okay.
let's go back to n. What's the question? So n is actually these values:
Hmm.
1,
Okay.
1, 0, 10, 20, 16. So these values are what we are going to compute
Oh,
to get the roots of them. So these are
okay.
the roots
Okay.
of
Okay. Okay.
those
Okay. Okay.
values.
Okay.
So
Okay. Okay.
16
Okay.
here is 4, 25
Okay.
is 5, and then
Okay.
10, 24 is 32. And then this
Yes.
is 1. So this one, it says when it is, this one is, I think 1 doesn't have roots, so just return
Mm,
1, and then
okay.
negative return that. So
Okay.
this is the n.
Okay.
Okay, so
Okay. 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 And also, because of course the support function also has to be defined before the recursive function because in C it starts reading from the top down,
uh, which
right?
one?
So our support function,
Yes, this is the support function.
yes. So we had to declare it at the top, or define it at the top
Is it
because
this one?
so the whole function, like the end support, we had to define it the whole function at the top before the recursive
Yes,
function.
yes,
Yeah,
yes, yes.
because it would. Okay. All right. All right. All right. All right. All right. That's understandable.
So this is actually what you are going to. Others have more than two functions. Like,
Mm,
so if you understand it, like, you'll
mm-hmm,
be able to kind of
mm-hmm.
wrap your head around, because it's
Okay.
question tax 8 or 7 like this. I think it's tax 7.
Mm-hmm, mm-hmm.
The functions were three.
Okay.
We have the one that counts the number of strings, because
Mm-hmm.
I don't know if you have gotten to that part.
No, I haven't. I
Okay,
didn't look at that at all.
okay. So
Let
like,
me check.
depending on the task, the function
Mm-hmm.
may be more or Yes,
Okay. Okay.
because sometimes you can't combine them in one function. You have to
Okay.
kind of, okay. So, for instance, if you want to add numbers,
Mm-hmm.
you can write function just for adding numbers,
Mm-hmm.
and then you can write another function just for subtracting numbers. So
Mm-hmm.
anytime you need to subtract or add, you call them.
Mm-hmm. Mm-hmm. Mm-hmm.
That's the purpose of recursion, like
Okay.
what we are doing,
Yeah.
for you to be able to separate your code.
Mm-hmm.
So you have a function that add, you have a function that subtract, you have a function
Okay.
that divide. So
Okay.
anytime you don't have to write all those codes in one line or in one
Okay.
file.
Yeah.
So
It's,
anytime
is
you
it that
need,
it's impossible, right?
yeah, so anytime you need something, like, you just call it.
Mm-hmm.
Yes. A
Okay.
typical example is the standard library. It has
Okay.
already been written.
Mm-hmm.
So if you want to say, if you want to compare strings, you just
Mm-hmm.
call the string cmp or something like that.
Yeah.
You just
Yeah.
call it, and then it will do that for you.
Okay.
Yeah. So
So for some of the tasks, I realized that I was calling because like the way this one string comp has been it's telling us that, hold on, let me just go to it. So it's saying that s2, so write a function that compares two strings and returns one if the string can be considered identical, otherwise return zero. So we have already done a compare,
mm,
right? Okay, but probably this would entail more, and I'd need to.
which
I'd need
one is that?
the eight. That's what I'm looking at.
Okay, the eight. I've not even done it. I was looking at
Okay,
it, and then I have
okay.
not done it. I've done up to I think the seven. Yeah, the seven.
Seven, the palindrome,
Yes,
palindrome,
yes, yes.
palindrome. So the palindrome is just to switch the first and last.
No, palindrome is like your the
The
first
first
string.
and last doesn't change the so like we have here level. So level red from the back is still level, red from the front is still level.
Yes, yes,
Right.
yes,
Okay.
yes, yes. So
Okay.
I don't know. Let me see if I have that one. Say a cost step by step, Biana.
Yeah. So let's look at the yeah,
That's six. Okay,
six.
five. No, are you okay with the five?
Yeah, I'm okay. I'm very fine with the five now. Very fine with the five now.
Okay, so okay, now the five, you can do away with the five for now. So this one, six in the crowd, so then
Right
seven.
function that